Going over this warm-up, the first thing we're going to look at is with Hannah. You can tell that her slope is a rate of 3 miles per hour, and she walked for 3.5 hours. So to find her total distance, we could do 3.5 times 3, which would be 10.5 miles. So this is Hannah's total distance. Now Penelope, they give us the graph, so we're going to have to find the slope from the graph. Now the graph does tell us her total distance, and that is at 3.5 hours. She was at 7 miles. So her total distance was 7 miles. And then to find the slope, since it's a graph, the easiest thing to do would be to do rise over run. So we're looking for 2 easy points to connect to. So I would start at the 0, 0, and probably end here at 1 and 2. So that means we have a rise of 2 and a run of 1. So Penelope's slope would be a rate of 2 miles per hour. So to compare and contrast, there's not many. The main comparison would be that they walked for the same amount of time, 3.5 hours. The contrast would be their slopes are different, along with their total distance. So again, the comparison, they walk the same amount of time. Some contrasts would be Hannah walked faster and further. And that would be the main answers to this problem. Going over the homework from yesterday, we are on page 190, which had problems 1 and 2. Looking at domain and range of your graph, make sure that it is an interval notation with the inequality signs, since it does have a start and a stopping point. And remember, we do call this continuous. The initial value of f and x, if you plugged in 0, you would get -2 from the table, and the same thing with g of x. When you plugged in 0, it was -2. The range, remember f of x and g of x simply mean y, so we can replace those into the interval notation. Number 2 is going back to example 2 from the notes. Knoxville had 5 inches in 2 hours, which is 2.5. Atlanta, it told us the slope was 0.5. So there was 2 more inches per hour in Knoxville than in Atlanta, subtracting the 2.5 and the 2. Going over to page 191, here are your answers to page 191, so take a minute to look these over and talk about it with your classmates before I scroll it up. So here are your answers to 4, A and B, 5, A and B. Don't forget domain uses x, range is your y, which we're representing with your function notation, generally f of x or g of x. I'm going to go ahead and scroll it up. If you're not done discussing answers, you can always pause. And then finally, here are your answers to number 6. We're only going to be doing part of 6-6, some of the important things that we need to know. The first one is on page 196, so go ahead and flip to that page, please. We're looking at a family of functions, which is defined as a set of functions whose graphs have the basic characteristics in common. So the function that we're looking at, the original one, is f of x equals x, which is right here. And anything that is a variation of it, it could be 2 times x, or maybe a half times x, or maybe 2x plus 5, anything like that, they're still all going to form what kind of a function? And the answer to that should be a linear function. Now, the most basic function of any family of functions, and we'll be dealing with several types, right now we're focused on linear, is what we refer to as the parent function. Think of how this makes sense. Your parent is the original, and then you are a variation of them. There are some things you have in common with them and some things you don't, but they're the parent, you're the variation of them. The parent function for linear, which is what they explored in the first two, is f of x equals x. This is your very basic function, and then anything we do that changes that is a variation of it. Parameter, which is the third vocab word here, is one of the constants in a function or equation that determines the variation. For our linear, there are 2 parameters, and they're what changes x. The first parameter is your m, and of course m stands for, hopefully we all said slope, and the second parameter that can be changed is your b value. Which is the y-intercept. Now, if we go back to look at our most basic function, the f of x equals x, up here, what would the slope be for it? Remember, slope is always attached to x. The slope for that should be 1, because it's 1x. There is no b value, which means your b value would be 0. So this parent function starts at the origin at 0, and then has a rise of 1 over 1. So up 1 over 1 to get to your points. So again, for any linear function, your parent function is your f of x equals x, whereas we just discussed the m is 1 and b equals 0. You can always change the m or the b, or both, depending on what they're asking you to vary between them. So take a moment, look on the left, look at what's the same, what has not been changed in the equations on the graph on the left above. And here's the left one. So take a moment to answer question number 9. Pause and then unpause when you're ready. Hopefully you realized on number 9 that the parameter left unchanged were your m, because all the lines have a slope of 2. We're going to go ahead and also look at the graph to the right and look at what is unchanged on the graph to the right. So go ahead, take a second to do that. Hopefully we all realize that on the graph to the right, the y-intercepts were unchanged this time, the b values. The slopes were different, but all of them had the same y-intercept of 1. Not only can linear equations be modeled with parameter changes, but so can linear functions that describe word problems, any real-world scenarios. Changes in them can be analyzed by looking at what has changed. And so we're going to look at an example together and then reflect on it. Looking on page 197, we have a gym who's charging a one-time joining fee of $50. So there's your starting amount, and then every month you're paying them $25. So the total cost is C of t equals 25 times your time plus 50, and time is in months. So that is what we're referring to as our reference. That's our original for this problem. And we want to describe any impact that different situations can have. For example, maybe they run a special and they decrease the one-time joining fee, which means instead of starting at 50, it's going to start lower, which they sketched the blue line to show lower than 50. However, it does have the same slope, so it's going at the same rate. So that parameter could be changed. Maybe the gym is keeping the $50 startup fee, but they need to raise the monthly fee in order to pay for equipment repairs, to fix up the place, whatever it might be. Well, if that's the case, then they would have the same y-intercept, so it would still start at 50 here, which is what they're showing here. But the slope would be steeper because it's going to be a higher rate that they're charging you. So any line that's above the black one going at a steeper rate, steeper slope, it would be a appropriate parameter changed. There is no change in the domain or range on this one because you're starting at 50 and you're still going up depending on how many months you have your membership. So number 10, you're going to answer this question here in a second. It says once a year the gym offers a special in which the one-time joining fee is waived for new members. And they want to know what impact would have on the graph of the original function, C of t equals 25t plus 50. Go ahead, pause this to answer that question. Compare your answer to a shoulder partner and then unpause this to make sure you have the correct answer. That special offer will not affect the slope, so the graph will continue to have the same slope. But because the joining fee would no longer be $50, it would be waived. That means the y-intercept would be 0 instead of 50. If we were to rewrite this equation, then we would have C of t, and they did not ask you to do this, but just keep that in mind. Your slope is staying the same, so 25t. You no longer have plus 50, you have technically plus 0, but we don't write that plus 0 because it doesn't change our problem at all. So this would be the new equation for that joining fee being waived.